Hello and welcome back to my workbench. It is time once again to fix something. Today on the workbench I have a PS5 FAT model CFI-1115A, and it is, I believe, supposed to be no power, no beep, no signs of life. It has been worked on quite a bit apparently. I'll put up the description on the screen, but basically it has been worked on a lot around the Wi-Fi module. The south bridge has been replaced. A lot of work. So, yeah, I'm not sure what we're going to find when we get in here. But apparently it is now left as no power, just dead. Doesn't beep, doesn't try to turn on. So I'm just going to go ahead, instead of trying to turn it on, I'm going to just take the covers off and get down to the circuit board, and let's just see what we see in here, shall we? All right, well, we are down to the circuit board. And yeah, the seller did warn me this thing was in rough shape. It's obviously had some roach infestation. You can see corrosion, it's some signs of corrosion in certain areas. Been a lot of work around the Wi-Fi module. Got some capacitors were replaced, probably because of corrosion. A lot of heat, discoloration around the south bridge there. Both sides of the board. How well that shows up. Pretty dark right in that area around the south bridge. So, yeah, she's had a fair amount of work. Let me take a look under the microscope at this south bridge area. And quite a bit of flux still there. Looks like all around there underneath the south bridge. So we need to clean that out. I have not looked at it from the side. Let's do that right quick. Let me pull my microscope off the side of the bench. Let's look at it from the side. Yeah. Okay, well, some of the balls are melted and some of them aren't, it looks like. Some of those in the middle, you can tell. Yeah, not really soldered down, is it? Can you see that? Some of those in the middle of the of this side of the south bridge did not quite melt. How about this side? Those look a little bit better. And this side, not sure about those on this corner over here. Are they all the way down? I'm not sure about that. Okay. Let's look at the other side of the board. The back side of the south bridge. Okay. Now the first thing I notice, this diode has been removed and put backwards. Yeah, that stripe should be over here. And this is the diode that separates the 3.3 volt rail coming out of that RT5126 or DA9065, whichever one it has, the main PMIC for the standby power. It isolates that from the battery voltage, the clock battery, that CR232 battery on the other side of the board. So it's probably maybe causing a problem there. I don't see anything knocked off. We do need to return that diode around. Let's see. How about this side of the, yeah, then some jumpers made there. That was cut. That's part of an antenna network, looks like. I see flux there. That's been cooked pretty good. Our fan connector. Let's look at this Wi-Fi module from the side. Well, looks like good balls under there. Let's look at the back of the Wi-Fi module. It looks like some capacitors have been changed out. May or may not be sitting down quite right. Yeah, you can see the signs of the corrosion like on that pad there. That's just a test pad. It wouldn't cause an issue. So, first thing to do before I put power on this board is turn this diode around the other way. Let me make sure this diode is still good. Yeah, 0.31 seems to be fine. Let's reverse that diode. Okay. I'm going to guess that that has drained our battery. All right, the battery back up for the clock. But that won't keep it from turning on. It'll just keep the clock from keeping time when it's unplugged. Okay, let's get some power on this board and see what it does, shall we? Let me add this window. There we go. Let's see what kind of current draw we get. All right, let me give it 12 volts. Double check my polarity, looks right. And we draw no current. Well, 5 milliamps. Okay. 5 milliamps. So our south bridge is doing nothing. Let me take a look to see, is this BIOS IC been off? It has not been off. That looks like original soldering. So what do we have in the way of voltages and what do we not have? 3.3. We We have 3.3. 1.15, we have that. Do we have, I believe this is a, oh, nothing there. Is there 2 volts? We have our 2 volts. And we have 3.3 getting to our NOR. We do. We have the basics. We have the start of something. Of course, our 5 volts is there because we have the 3.3. I am wondering if we're trying to, if this oscillator is running on the other side of the board. Let's crank up the scope. And let me double check. I'm going to assume this battery is dead because of the way that diode was turned. Yeah, we're pretty dead. 0.045. Might as well take that out. That is doing nothing for no one. Are we getting our rails to our Wi-Fi module? Just kind of curious. 1.8 and a 3.3. So the Wi-Fi module has its voltages. That's good. Let me get this scope set up. All right, I've got my microscope and my oscilloscope set up. And we're going to look at this crystal. This is behind the south bridge. We're going to look on these test pads. And I'm not seeing anything. So I'm going to say that 32 kilohertz oscillator, the clock here, crystal oscillator, is not running at all. Okay, so, of course, we also know the south bridge is not sitting down properly. The board is on. I do have 12 volts to it. I'm going to turn it off. Let me try to heat this up and try to flush out from under it. But I got a feeling it's just not set down properly. So we'll flush the flux out from under it. We'll give it a little bit of heat. Let's see how this looks now. Still got flux under there. Let me try that again. Is that any better? It's a little bit better. I still got some on this side. But yeah, the chip is definitely not sitting down properly. If you look right there, that ball's not even making contact. So At the very least, we're going to need to reflow this thing. Let me see if that made the oscillator run. Probably not. We're probably not getting some rail that we need into the chip. Oh, wrong side of the board. And my leads came loose. Of course they did. Okay. Turn the 12 volts back on. Do we have anything here? No. Okay. I need to put this probably on a preheater and see if I can flow this south bridge down a little bit better. Either that or it's going to need a reball or a replacement. But I'll try seating it down with some after I preheat the board, giving it some heat from above. We'll give that a try. Of course, it could be bad, but we'll give it a chance. All right, well, with our south bridge seated down a little bit better, we hope, and I flushed out from under it, let's give this board 12 volts and see if she draws any more current. Yeah, oh, there we go, 300 milliamps, and come back down. All right, I like the looks of that. I think this board will try to turn on now if it doesn't have any other issues. I think I may go ahead and touch up some of the soldering, if you can see, around these capacitors there. Maybe get some of those to sit down a little bit better. But, yeah, there's been something going on around these fuses right here. Fuses for the Blu-ray drive have been messed with. Let me look at that area. Yeah, let's look at that area. All right, well, looking in the area of these fuses for the Blu-ray drive, F5401 and 5402, they have been kind of replaced with an oversized fuse. Here's what should be in here. It's a 2.5 amp 0402 size is what should be in there. So we're going to swap those out with the proper ones and do a little cleanup around that Wi-Fi area. and see if this, you know, maybe our Blu-ray drive will work. I hope. But those are way too big. Not that they wouldn't work electrically. Okay, let's see what it'll do. All right, I think it's time for a big test. See if she'll do something, anything. Maybe give us a light, a beep, a picture. All of the, oh, beep on off. Beep on off. Okay, so we have deeper issues here than just a simple south bridge. Okay, let's get it back out. Okay, back over at the workbench. Let's see what we have and what we don't have in the way of voltages. 1.35 for the RAM. Yeah, I think I saw it there for a moment. Very quick moment. This is the APU voltage over here. See if we get like 9/10. Yep, it was quick, but it was there. And what about this one? Yep, that was there. What about, this should be like a 0.75. Yep, like I saw it momentarily. And this is a 1.8. Yeah, very quick. It's moving on over to here, this side of the APU. I didn't see anything. Let's try it again. No. All right, that would be the 6-phase. This would be the 2-phase rail. No. So none of the rails on this side are trying to come up. These are both about 9/10, 1 volt. They should be. So we are getting our 5 1/4 down here. Yeah, it's real quick, but it's there. I think this is a 3.3. Yep, that's there. I think this is a 3.3 right up here. Let's see. Yep, that's there. So, is our controller for all these APU rails not turning on? I haven't looked at that area of the board, see if there's any issues. Let me get the board out and take a look in that area. Could it possibly have had some work in that area in the past? Doesn't look like it. Not that I can see. Let me look under the microscope. Because this is going to be what's not running for some reason. Looks like is that a hole in the top of that chip? I think it is. Which I think that's a digital transistor of some kind. Let me kind of run something across the top of it. Yeah. A gouge, if nothing else. Keep that in mind. A little discoloration on top of that chip. I think that's just some alcohol or flux or something. The chip does not look like it's been removed. Nothing obvious anyway. But that is something to note. Let me take some readings around that area. Switch back so you can see the meter. What if I just check, say, resistance to ground? .76 megohms, 21 k ohms, and 70 megohms. So we're in the megohms there, we're in the megohms here. 22 k ohm to ground there. That's with black probe on the ground. What do I get? I'll reverse, put red probe on ground for diode check, and let's just see what do we have. Open. Capacitor charging up there because I see a negative reading. And nothing. All right, let me have another board here. This is a working EDM 020. Let's take a look in that same area. Still in diode mode. What do we have here? Nothing. Well, about the same reading and nothing. So it may just be a mark in the top of that transistor. I'm back in resistance mode. The negative reading there's some voltage there somewhere. In the k ohms, climbing. in the K ohms and climbing. Oh, now I read. I took the probe off, put it back, and I'm in the mega ohms. So, yeah. 22 K ohms. That looks the same, so it's probably not our problem. Probably not. We'll keep it in mind, though. Okay. Let's get our bad board back up here. Let me look behind that chip. Yeah, that's a 3.3 volt regulator there, and it looks fine. And we did have 3.3 coming out of it. Could we be missing another rail? I know. Go back to the other side of the board. This chip gets several rails. And I want to say one of them may be like a 1.8 or 2 volt. Let me see how many rails this chip gets and if we have them. All right, well, we may be onto something. Do you remember that component we found with the hole, what appears to be a hole in the top of it? I'll show you this guy here in the middle of the screen. Yeah, turns out he's pretty important. That's a P-channel MOSFET. And if I can show you where it is, that's him right here. And he's responsible for sending 12 volts into our XPDE chip, the chip that generates the 6-phase and 2-phase rails. Now, it's not for power, it's apparently for sensing, because if you look at it, it switches 12 volts to here, or it should. It goes to a 20 K ohm and then a 1.6 K ohm to ground. So it is a sense. P-sen, V-in sense. P-sys, whatever. It's sensing that there's 12 volts is on and is working. So you should get, I've done the math, it's about 0.88 of a volt, about 9/10 of a volt, but you should get right here. If you get 12 volts and it divides it down right here through this 20 K and 1.6 K to ground, about 9/10 of a volt to there. Now, let's take a look at our board and see what's happening there. All right, I have a button hooked up and I've got an LED board hooked up. And we are going to measure this signal right here, which is this is a digital transistor that drives the MOSFET. And so if let's see, where's my button? We're low, we go high, and we go back off again. So that's the signal from the south bridge, right there, that pad. Now this is after the digital transistor. You see how it's high right now because we're not on. We're 11.295, and that's basically 12 volts going in here to the gate of this P-channel MOSFET. And this should go low and should then turn this on. So if we watch this point here, the gate of this MOSFET, 8.6. I'm not sure if that's low enough. I have to check on that. But it went to 8.6, and maybe there may be some leakage going on why it's not going that low. But if we look right here, I'm going to hit the button again. We never see the 12 volts comes out. We never see it. So I have a feeling this has failed. So that's my guess. Because this seems to be it tries to put, I would think this would go a little bit lower than the 8 volts that it goes to. But we don't know what kind of leakage is taking place in here. So we're going to get this swapped out with a donor and see if that makes a difference. I'm thinking it will. All right, that MOSFET has been changed out. Now, I'm still connected to my bench power supply, so I can't actually power this thing. It can try to turn on though. So what I'm hoping is going to happen is that we will get 12 volts switched out here, and my power supply should go into current limiting because it's going to try to come up and run. And I'm set for 2 amps of current limiting, and there's no way that's going to power anything. So I'm going to give it 12 volts right quick, like. And I need to connect my leads back. Just a moment. Probably help if I connected my leads. There we go. Now, give it 12 volts. See our usual little initialization of 300 milliamps and go back down. That looks beautiful. And what we should have is like 12 volts sitting here, waiting to be switched out to over here. So let me get my hand on the power button. And let's see if I switch right. I'm going to put my probe right here. Let's see what happens. Yes. Yes. I saw 11.9. All right, so now she's trying to turn on. She's trying to turn on these other rails over here. These rails that have been dead, I think are trying to come on now. So let me kill the 12 volts. Let me slip it back in the chassis, and let's see what happens. All right, we are back into the chassis and ready to see if it will come on this time. I have not tested yet to see if those rails are coming up. I have a feeling they are, though. I'm just gonna assume they are, and let's just see what happens. Yeah, lights are connected, fans connected. I thought I had the ribbon connector for the lights connected, but she's staying on. I think there's flux all in that ribbon connector. Let's see if we get a picture or something. Maybe? No? Please? No? What's it doing now? Oh, there we go. Yeah, I got to figure out why the LEDs aren't lighting up here, but I think there's flux. Every time I plug that connector in or that ribbon connector, it's spongy. Something feels weird about it. All right, we're coming up. Well, that's glorious. Okay, so it had an SSD in it at one time. They took it out. Okay. I think we're alive. I need to either replace that ribbon or clean it really well. All right, let me finish up some tidying up around the board here, and we'll put it all together and see what it does then. How's that sound? Well, this PS5 is fully reassembled. I have installed a game. Blu-ray drive is working fine. Connected to Wi-Fi, downloaded an update. All that went well. I did end up changing out the HDMI connector. It was kind of in bad shape, so I changed out that. It was original factory one. Changed that out, and I changed out the ribbon cable for the LEDs. This cable. It was in sad shape. The contacts on the end of it were so worn out and flared out. The copper had deformed, and it was touching each other. The contacts were shorting just from worn out copper flaring out the end of the contacts. I've never seen a ribbon cable so worn out before. But we're all good now. So I'm going to give this a good bit of testing, but I think we're going to be good with this one. Well, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up, and I'll see you in that very next repair. Bye for now.